Good morning. I am again repeating this class for recording purpose only. Those who have not listened carefully, they can follow this video. PMMC. PMMC means permanent. PMMC means permanent magnet. Permanent magnet. Okay. Moving coil. Moving coil. Okay. It consists of a permanent magnet, North Pole and South Pole. Okay. We can observe here that whenever this type of circuit is there is a magnetic field every time. Okay, from North Pole to South Pole. And now there is a current carrying conductor is placed. First it will go to spring, first spring, and there will be an aluminum former here. Aluminum former will be there. Okay, on that it will be wounded. On that it will be rounded. This is the first turn and second turn, third turn. Number of turns will be there, and after turn it will come back and it will be again go to spring, and after spring it will come out. There will be two terminals for any PMMC voltmeter or ammeter. There will be two terminals, positive terminal and negative terminal. Okay, meter will enlarge this one, positive terminal and negative terminal. This is the scale for that one. And this is the pointer at initial position. This is the setup for any meter. Okay. Now let's take this one as a positive and this one as a negative. See, there are some scenarios here. When positive, negative is there, some current which you have to measure, that current have to flow through this one like this. I current is flowing like this, and it will flow through this one. And as this is a current carrying conductor, and it will come back here I, and it will also go to the other spring, it will go outside. You have to measure this current, how much. That is the scenario. Okay. See, if it is 5 amperes, automatically this meter, this is 0, this is 5, and this is 10, and it will start showing 5 amperes. Okay. But how that moment came means, see, there is a principle here. What is the principle here is that whenever a current carrying conductor, current carrying conductor is placed in a magnetic field, it experiences a force. Okay, experience a force. That is very important. This force is very important. Okay, this is known as electromagnetic, Faraday's laws of electromagnetic induction. Okay, now see what happens if this is positive and this is negative. That is the first scenario. Okay, and now as it is experience a force means, now you can see from this diagram that this is the aluminum former. Okay, aluminum former, and we have shown here like that, and correspondingly this is the spindle. And for spindle there is a pointer attached. This is the initial position, this is other position, this is the final position. Okay, whenever that current is there, then it experiences a force in clockwise direction for this meter, for this color, red color currents. Okay, if somebody connected positive here and negative here, means they have to give the positive terminal of DC here and negative, but mistakenly they had interchanged here positive, here negative. Then current will be starting like this, and current will be coming out like this. Then what happens here, that here also it will experience a force, but the important point here is that it is in anti-clockwise direction here. Hence the pointer will start moving like this. That's why normally we place mechanical stoppers here, meaning on the screen you can see here that see, the pointer will be up to here. Okay, here there will be mechanical stoppers. That's why pointer will not go in anti-clockwise direction. Okay, next, now some person, we can see that this entire apparatus will work for only DC only. That is the first point. What if somebody connected to AC only? AC, not AC only, AC. This device does not work for AC. Tell me, what is the reason here is that? What do you mean by AC first? AC is a 50 Hz supply. 50 Hz supply. 50 Hz means 50 cycles of positive, comma negative. Okay, meaning total 100 times changes will be there. Okay, what is the meaning of this one is that you can observe here in this first positive will be there, negative will be there, negative will be there, positive will be there, positive will be there, negative will be there, negative will be there, positive. Like this in 1 second, how many changes are there? 100 changes will be there. And this meter does not, that meter wants to rotate, but in a span of 0.02 seconds, 0.02 seconds it can be changed. Anta fast ga magnet changes ni follow a pointer lead. That's why this does not follow like that. That's why this this pointer will not follow, but it can oscillate at that position, at the zero position only. At this zero position only, it will oscillate అవుతా ఉంటుంది. Okay, that is also important here. That okay, and that's why this meter does not connected to AC circuits, and it will not measure AC circuits. Okay, next. Here we just now we told that this experience is a force, right? Now we have to derive that equation of force. What is the deflecting torque? Okay. Now just now we have done force. The force equation is given by Lorentz force equation. Lorentz force equation. Okay. What is the Lorentz force equation? F is equal to BIL sin theta. This is a repetitive class only. Those who are listening, I am recording this class. I am again playing this one. Okay, sir, మీరు వచ్చారా? రికార్డ్ చేస్తున్నాను సార్ నేను క్లాస్. మార్నింగ్ రికార్డ్ చేయడం మర్చిపోయాను. స్టూడెంట్స్ కోసం మళ్ళీ రికార్డ్ చేస్తాను. ఓకే, అదిరామ్ సార్. Okay, F is equal to BL sin theta. As you can see here that this magnetic field and this current are parallel. That's why we substitute theta is equal to 90 degrees here, and F is equal to BIL. Okay, we will get that. And this is the equation for one turn only. Now we have n terms, right? That's why now the equation will be n BIL. Okay, and now we can go to for this position here, and this is the length. Let's talk. This one is the length is this one, and depth is d. Okay, you have to consider this one. Torque is equal to force into perpendicular distance. Perpendicular distance is d. Okay, NBIL into d. Okay, now L into d is area. Now we get a final equation as torque is equal to NBAI d, or d is equal to d. Okay, in yesterday's class, let's say this one as 1, and in yesterday's class we told that TC is equal to K theta for, this is for spring control. You can see here there are two types of springs, right? Two springs at the bottom and at the starting. This is the first spring. Okay, this is the second spring. Here spring control. That's why this expression, what is the condition to be satisfied? TD is equal to TC. Okay. TD is equal to TC. How do you satisfy this one? Is you have to substitute P naught here and K theta. Now that current you have to measure is proportional to theta. Okay, that's why it is a linear scale. Okay, that's why PMMC device is a linear scale. You can see here that it consists of linear scale. Okay. Next, this is the torque equation. Torque equation derivation ఎవరైనా అడిగితే ఇక్కడ వరకు చేయాలి and linear scale అని చెప్పి ఇది prove చేయాలి. Next, I have to come here. Here controlling torque is provided by spring, and this one has a very effective, efficient eddy current damping. Damping is taken by eddy current damping. We know there are 3 types of dampings here, but we are using here eddy current damping. Okay. Next, it is the low power consumption. We will see what are the advantages of it. It is a low power consumption. Why it is a low power consumption here is that remember that these are permanent magnets. Whenever there are permanent magnets, automatically low power. Electromagnet means you have to do extra power. That can be gone here. Next, it is a uniform scale. Theta is proportional to I. Very good. We got a uniform scale, that is a high sensitivity, and enables very small current to measure. Remember, this will be used for 5 milliamperes to 50 milliamperes. Meaning very small currents can be measured easily, but only up to 50 milliamperes only. For other currents we will use shunts. Remember, shunts and multipliers are used for measuring the other current. That is what this point is. Okay, this one is also over. One is also over. Sensitivity also over. Next, there is no hysteresis loss. Hysteresis loss means whenever we are using here a aluminum former have a, this is known as a BH loop. Okay, BH. I'll tell you. Yeah, if this area is very high, hysteresis loss will be high. Okay. Similarly, if the area is very small, hysteresis loss will be done. Aluminum has the thin hysteresis loop. That's why small or negligible hysteresis loss. Okay, that is one point here. Next, disadvantages are that this device cannot be used for AC measurement because of rapidly changing direction. Just we told that one. Next, it is used only for limited DC supply only. More expensive and most accurate design. Remember, because of accuracy, it has more expensive. These are the advantages. And frictional error, temperature error, we will see one by one. What do you mean by frictional error here is that, see, if you see the structure here, it consists of pivot, right? Pivot consists of structure will be actually looking like this, and this is the spindle, and it will be like this normally. Okay, and the spindle is gently placed on these jewel bearings. Okay, jewel bearings. This weight of the jewel bearings will and the spindle and the torque produced. This ratio should be high to have a friction error. Very less. We can say that this friction error can be reduced by jewel bearings or high torque weight by ratio. But whatever you do here, this error is greater than MI instruments. Next, temperature error. Temperature error can be reduced by using stamping resistor. Stamping resistor is a combination of manganese, copper, and nickel. Manganese has a negative temperature coefficient. That's why whenever temperature increases, resistance decreases. Okay, that type of is a negative temperature coefficient, manganese. That's why it can be. And other compensation is the springs are connected in opposite direction. As springs are metal, it depends upon the temperature. That's why. Next, frequency error. It is absent because the meter is used for only DC. Obviously, there is no AC contact. Stay magnetic field means external magnetic field. External magnetic field cannot affect because these are permanent magnets. Permanent magnets are already at a peak strength 1.6 Tesla. That's why other magnetic field can't affect. No compensation required because of stronger magnetic field inside the meter. Next, hysteresis in BH loop, aluminum plate or in BH loop. These are already completed. We discussed this one. These are the torque equation. And how do you extend? I told this this is used for only 5 milliamperes to only 50 milliamperes, right? But our meters are up to 5 amperes or 10 amperes. How do you measure? ఇలాంటి డివైస్ ని ఎలా మెజర్ చేస్తుంది? Or It can be up to from 200 millivolts only, up to, but it can be using DC of 200 volts or 500 volts. But how do you are doing like this? For the same, we are using here for currents, we are using here shunts. For voltage, we are using multipliers. Okay, we are discussing that concept now. Next, see, basically PMMC device can be represented like this. See, it can be represented like this. Only resistor will be there, RM. Okay, and this is the voltage VM correspondingly. Okay, now we have to measure the new current or extra current. For extra current, we are let's say IM. For your understanding, I am taking this and as a IM value as a 1 ampere. Okay, but I want to measure 5 amperes. Okay, that extra part will be go through like this, and this resistance value you have to find out. We know that this will be 4 amperes. 4 amperes. Okay, 4 amperes. But for your understanding, I have taken like this, but we should not consider these values. Consider this value. Now we will generalize this. For example, we have to increase the range of this ammeter from IM to I. Okay, this is small or volt, you can call. This is large and new current. Remember, I am telling like this, you will get. Then here it will be I will be there. What is the current flowing here? I minus IM. As they are connected in parallel, this one and this one are connected in parallel, their voltage drops are same. What is the meaning of that one? IM RM is equal to I minus IM, that is the current flowing to the and R shunt. We want R shunt value. R shunt is equal to IM RM by I minus IM. Okay. Now rearrange this one. M minus 1 will get. R shunt is equal to, and M is equal to I by IM, or new current by old current. You have to remember like this. Okay, this is the procedure. Similarly, if you want to extend the same like this only voltage, meaning previously up to meter it can measure only VM, old value, and small only. Now we have to same voltmeter to capital V, that is new and large. Okay, meaning same IM and RM up to VM only, up to here. Okay, but we have to measure extra voltage, that will be taking care of multiplier, that is known as RSC, and this is the extra voltage up to. Okay, you can say that here also the current is IM only, because they are connected in here IM only, same IM only, here also IM only. Okay, as the currents are same, we can say that voltage by ratio, voltage by resistance ratio should be equal in both, meaning EM by RM is equal to V by RSC plus RM. Like this we can. Okay, now we want RSC value. Remember that point. Next, meaning RSC plus RM is equal to VRM by VM. RSC is equal to M minus 1 into RM. Okay, RSC. This is the expression for the multiplier. Remember, M is equal to capital V by small VM, meaning old, new, every time it is new by old only. Remember, I am saying, because during problems you have to find out the M value very fast. And this is the extension of using extension of PMMC using multiplier. Okay, now we will see some problems on that one. Next, see, the first problem here is that a manganese swamping resistance is connected in moving coil consists of a and short. Why manganese swamping resistance? Swamping resistance, just now I told that swamping resistor consists of a manganese and it is used to compensate what? Temperature error. That's why the first answer is minimize the effect of the temperature. Next, the effect of stay magnetic field on the torque is maximum when the operating field and the stay field is. Meaning I told that here there is a north pole and there is a south pole, right, and there is some magnet. Okay, now there is other stray magnetic field. Stray magnetic field, if it is like this, it will not disturb anything. But if it is like this, parallel or this side, it can affect your magnetic, real magnetic field. That's why there is a concept of shielding. Shielding, not for PMMC, for other devices. Okay, that's why this orange line and purple lines are parallel. That's why the answer is parallel. The effect will be maximum while parallel only. Next, here one problem for torque equation of the PMMC had given n is equal to 100 and length is equal to 10 into 10 to the power of minus 3. Depth is equal to 20 into 10 to the power of minus 3. Next, magnetic flux 200 into 10 to the power of minus 3. Next, current is equal to 50 into 10 to the power of minus 3. Okay. Now, what is the formula for torque? TD is equal to NBIA. Okay. N you substitute, B you substitute, I you substitute, and A is equal to L into D. If you substitute, you will get a 200 micronewton meter. Okay, that is the unit for that. Now, next, PMMC is connected to a series combination of DC source and AC source. See, just now I told that this will work for only DC only, DC only. Remember that point, only DC only or 5.2 volts only. It will not show anything other. If somebody connected AC only, remember only AC only, that answer will be 0, 0. It is the pointer oscillated 0 position. DC only, it will show that whatever the DC value, that one. But if you have AC plus DC both, it will show only DC only. But if you have shown rectified AC, then it will show average value. Remember, if you have some square wave like this, okay, but if it is rectified, it will be looking like this. Okay, looking like this, then it will show average value of that waveform. Okay, these are the problems related to PMMC and extension. In extension also there are some problems here. See, galvanometer, don't confuse with the diagram here. Galvanometer, a small current is 10 milliamperes, and you have to directly you can go not to this problem, you will do the other problem and you will come back here again. Okay. Next, see, we will see first. DC ammeter means PMMC, no doubt. It consists of a resistance RM value how much? 0.1 ohm, and it has a current range 100 amperes, and now it has to be extended to 500. Now tell me, which is old, which is new? Old is this one, new is this one, or small is this one, or big, large is this one. You know now what is M. M is equal to new by 500 by 100. We will get a ratio of 5. Now we know that R shunt is equal to Rm into M minus 1. Rm is 0.1, 5 minus 1 is 4, 0.1 into, divided by, R shunt will be divided by 4, it will be 0.025 something, 025, that is the answer. Okay. Similarly, for this one, see, you have to do some problem. This is the resistance RM value, 5 amperes, 25 amperes. Now, is this an ammeter, voltmeter? Ammeter means connected parallel. Parallel means answer should be in these two. You have to find out this problem. Pause the screen and do this problem. Next, already that has been done here. Already చేసేసారంటమ్మా. అప్పుడు ఆర్ షంట్ వాల్యూ మీకు ఎంత వచ్చింది? ఇక్కడ ఆర్ షంట్ వాల్యూ 100 వచ్చింది. అయితే పాత కరెంట్ ఎంత అంటే స్మాల్ ఐ ఓల్డ్ ఈజ్ ఈక్వల్ టు 10 మిల్లీ యాంపియర్స్. ఓకే, దాని యొక్క రెసిస్టెన్స్ ఆర్ఎం వాల్యూ 1000 వచ్చింది. అప్పుడైతే కనుక ఐ న్యూ అడుగుతున్నారు. ఐ న్యూ తెలుసు మనకి. ఇదే ఫార్ములాస్ లో దాన్ని కూడా ఫైండ్ అవుట్ చేయొచ్చు. ఆర్ షంట్ ఈజ్ ఈక్వల్ టు ఆర్ఎం బై ఎం మైనస్ 1. దట్ ఈస్ ద ఫార్ములా, రైట్? ఆర్ షంట్ ఎంత 100, ఆర్ఎం ఎంత 1000 డివైడెడ్ బై ఎం అంటే ఏంటి? న్యూ బై ఓల్డ్. ఇప్పుడు వాళ్ళు న్యూ అడుగుతున్నారు. మనకి న్యూని ఐ అని పెట్టేసేయండి, ఓల్డ్ని 10 మిల్లీ మైనస్ 1. ఇది సాల్వ్ చేస్తే ఐ ఫైండ్ అవుట్ చేయండి. Okay, these are the doing of 3 different extension problems. Extension problems are very important, and you can see here that this is the voltmeter, right? It consists of G minus అని ఒక టెర్మినల్ ఉంది బ్లాక్ లో, తర్వాత 3 ఉంది, 10 ఉంది, 15 ఉంది. ఇది ఎలా ఉంటుందంటే just now I told that any PMMC will be looking like this, IM and RM. Okay, this is the meter. Now you can say that just now I told that up to 5 to 50 milliamperes only we can use PMMC, but 3 కూడా మనం మెజర్ చేయలేం. దాన్ని ఎలా మెజర్ చేస్తున్నామంటే there will be like this, ఇలా చాలా కనెక్షన్స్ ఉంటాయి. ఒక షంట్ అని కాదు, మల్టిప్లైర్స్ కూడా చాలా ఉంటాయి. ఇట్ కన్సిస్ట్ ఆఫ్ యువర్ ఓకే లైక్ దిస్. ఇది అంతా కూడా అమ్మీటర్ ఎక్స్టెన్షన్ కోసం ఉంటుంది. సిమిలర్లీ ఇఫ్ యూ వాంట్ it will be looking like this. This is one, this one. This is for 3 volts, this is for what is that 10 volts, and this is for 15 volts. ఎప్పుడైతే 15 volts కనెక్ట్ చేస్తామో ఇది క్లోజ్ అవుతుంది, ఇలా వస్తుంది మనకి ఈఆర్ఎస్సి వాల్యూతో వస్తుంది. నెక్స్ట్ 10 volts అన్నప్పుడు ఇది క్లోజ్ అవుతుంది, ఈఆర్ఎస్సి 2 వాల్యూతో వస్తుంది. 3 volts వచ్చినప్పుడు ఆర్ఎస్సి 3 వాల్యూతో వస్తుంది. ఇలా ఉంటుంది అనమాట మనకి ఏదైనా డివైస్ అన్నది. కరెంట్ అయితే ఇది, వోల్టేజ్ అయితే ఇది. ఓకే, దిస్ ఈస్ ద క్లాస్ వి రిపీటెడ్ ఫర్ యువర్ క్లాస్. మీకు ఎవరికైనా మెటీరియల్ కావాలని చెప్తే నేను ఆల్రెడీ ఫార్వర్డ్ చేసేసాను. గో త్రూ దిస్ వన్ అగైన్. టుమారో క్లాస్ ఇఫ్ యూ హ్యావ్ ఎనీ డౌట్స్ ఆస్క్ మీ. దిస్ ఈస్ ద కంప్లీట్ క్లాస్ ఫర్ PMMC and correspondingly problems, gate problems. Okay.